Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. Over the last few lectures, we have been discussing about olefin metathesis, particularly from the perspective of their origin, their mechanism, also the active species, so on and so forth. So, today we are going to look up the various kinds of metathesis reactions that are available in order to understand the scope and the breadth of this fantastic reaction. Now, in the context of discussing olefin metathesis, what is required is that we go back in time, back by about 70 years to mid 50s to really understand this metathesis reaction. So, about this is about 60 or 70 years back, and olefin metathesis was born out of olefin polymerization. And this is so to say that there were some unexplained observation which eventually led to the development of olefin metathesis chemistry. The olefin metathesis in that way is a very important reaction in the sense that it sort of put in place many unexplained or many different discoveries, small discoveries in proper perspective to give rise to this olefin metathesis reaction or the family of olefin metathesis reaction. And the first that comes in mind is this active species, which is metal carbene complexes. As the active species for olefin metathesis. So, this was an interesting development which was synthesized contemporary around that time by Fischer and Strock, and gradually it turns out that this whole olefin metathesis is catalyzed by these metal carbene chemistry. And at that point of time, unexplained observations finally fell in place all unexplained observation finally fell in place, giving rise to a family of olefin metathesis reaction. And this was possible because of the elucidation of the mechanism proposed as well as demonstrated by Chauvin, followed by many other including Tomcat contribution we have discussed about in the last class. and as it turns out that then the several unexplained observation with regard to this reaction of olefins, the involving cutting and stitching of olefins of different types, all of them suddenly become explainable using this olefin metathesis mechanism, and all of them then fall under the umbrella of olefin metathesis. So, what was observed that a group of about 10 to 15 different reactions proceeding along this pathway of olefin metathesis, which follows by 4-membered metallocyclobutane intermediate and proceeds with a metal carbon active species came in being, and that sort of explained the unexplained phenomenon of a variety of reactions, which eventually gave rise to a family of metathesis reaction. And in today's class we are going to take a look at different types of metathesis reactions which are known today and what they are called. To begin with, the first is self metathesis. And this is about the reaction of the same olefin with itself, as is shown over here. So, what we have over here is same olefin, one type of olefin giving rise to two different olefin, and this is what is called self metathesis reaction. The next in this series is cross metathesis. So, this is explained in this set of example, where we have a olefin R1 R2 reacting with olefin R3 R4, giving R1 R3 plus R2 R4. So, what we have in cross metathesis is the fact that two different kind of olefins reacting to give two other olefins R1 R3 R2 R4, which were not in existence. So, in self metathesis we had observed one kind of olefin giving rise to two different kind of olefin, the same olefin reacting to itself. In cross metathesis what we observe is two different kind of olefins resulting in two other kinds of olefin. So, that is called cross metathesis reaction. Another interesting type of metathesis reaction is called ADMET, acronym ADMET, and in expanded form it says acyclic diene metathesis polymerization. And what ADMET is polymerization between two terminal olefins, as is shown over here. Giving rise plus ethylene, which comes from the polymerization of this terminal chain end. So, this end would give rise to the formation of ethylene, and here too what we observe in admit that this is a polymerization reaction where one type of alpha omega olefins giving rise to a polymer and olefins ethylene, this is what is called admit. So, all of these sort of proceeds in the by using the same mechanism, and what we see that in all of these cases the number of double bond is conserved, and that is the beauty of this olefin polymerization process. The next in this series ROM or ring opening metathesis and this, which is a cyclic olefin, reacts with ethylene giving ring opening metathesis product, ROM product. So, what is notable over here is that two different olefin, this is olefin number 1 and olefin number 2 gives the metathesis product, which is olefin number 3, and that the product is the alpha omega acyclic olefin where the ring has been opened, and hence is the name ring opening metathesis or ROM reaction. This is called ring opening metathesis reaction. The fifth variant in this series of metathesis reaction is called ROMP. So, the fourth variant what we spoken about was ROM, ring opening metathesis reaction, and this is ring opening metathesis polymerization reaction. This has the acronym ROMP and it stands for ring opening metathesis polymerization. And this is also nicely demonstrated by this, represented by this equation, where when there is n mole of cyclic olefin reacting to give the corresponding polymer, where the number of rings have been conserved, and this is a very nice reaction where a polymer is obtained from cyclic olefins, and the result in formation of polymer results in opening of the cyclic olefinic ring. Then proceeding further, another variant of this metathesis polymer is called ROCM, ring opening cross metathesis. This is an interesting variant as well, and this is called ROCM, or in an expanded form called ring opening and this is given by this nice equation where this bicyclic compound reacting with another olefin where one of the double bond undergoes metathesis and one of the ring opens up to give the following compound. So, what is to be noted here is the fact that these olefins react where these bonds undergoes metathesis reaction of each other and these rings open up giving rise to this product with two olefinic bond. So, this is called ring opening cross metathesis, because in this case the metathesis happens between two different olefinic bond as is highlighted over here. The seventh variant is exactly opposite of what we had as observed for ring opening metathesis, and it is rightly called ring closing metathesis. It is exactly opposite of ring opening metathesis and hence the name becomes ring closing metathesis and acronym is RCM. Now, this is given by this reaction, illustrated by this reaction as is shown over here, olefin becoming acyclic alpha omega olefin giving a cyclic olefin plus ethylene. And here the point to note is just reverse of what we had observed. It is intramolecular metathesis reaction. So, one type one olefin results in two different olefin, one is a cyclic olefin, another is ethylene. So, this is exactly a opposite of ring opening metathesis where these two reacted to give this, but in RCM ring closing metathesis it is opposite, exactly opposite. This undergoes intramolecular metathesis giving rise to this and this, exactly opposite of ROM is RCM. Similarly, along the same lines, the next immediate variant which is number 8 in our case is called RORCM, and as the acronym suggests that this should be a very interesting reaction because it is ring opening, ring closing metathesis all at the same time. So, kind of very interesting that both ring opening and ring closing both happening in one reaction, and that is why it is called RORC, ring opening, ring closing metathesis reaction. RORCM, ring opening, ring closing metathesis, and this is beautifully illustrated by this example shown here. This giving rise to so, what is to be noted here that RORCM is also intramolecular metathesis, both one undergoing closing, another undergoing ring opening. So, this one is undergoing RO and this one is undergoing RC, ring closing. So, giving rise to the product. So, in RC what is happening is this end and this end are stitching up and this end is opening up. So, this is exactly what is happening, and in this case too, as we would observe that this is one type of olefin resulting in the other type of olefin. So, here we have a fragment which is 5, 6, 7, 8, 9, 10, and over we also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, it is exactly the molecule remaining this the total number of atoms remaining the same, only the position of the olefinic bonds and the structure of the molecule becoming different. The next in this series is alkyne metathesis, and they also come in various types, and what is interesting to note over here is the fact that alkyne metathesis are less explored and studied than the alkene metathesis reactions. However, having said that, this alkyne metathesis also proceeds by similar pathway, and they are very much studied as an extension of olefin metathesis reactions, or rather they fall in the larger group of alkene metathesis reaction. So, with this we come to conclusion of today's lecture, in which we had focused on various kinds of metathesis reactions and various kinds of olefin metathesis reaction, to say the truth, and the things that we have covered is starting from self metathesis. There are about 8 variant starting from self metathesis, where the olefin undergo metathesis with itself. Intermolecular metathesis is the self metathesis, and then we have cross metathesis, which is CM. Then we have another interesting one, which is called admit or acyclic acyclic diene metathesis polymerization polymerization. So, this gives rise to polymer acyclic diene metathesis polymerization reactions. Then we had seen our OM, ring opening metathesis, followed by ring closing ring opening metathesis polymerization ROMP, followed by ring opening ring closing metathesis ring opening cross metathesis, followed by ring closing metathesis RCM, followed by ring opening ring closing metathesis. So, there are about 8 different types of metathesis reactions that we have studied, these being 1, 2, 3, 4, 5, 6, 7, 8. So, the point to note over here is that now again going back in winding back 70 or 60 years, what is observed that all these 8 different types of reactions which at that point were extremely intriguing and complex to understand, and all of them involved cutting and stitching of different kind of olefins. Now, all of these sort of became all of a sudden explainable, and answer to all of this complexity could be solved with the mechanism which has been proposed for olefin metathesis as proposed by Chauvin. So, that help bring all these different kind of olefin metathesis reaction. All of a sudden it seemed that they are not different, but belong to the larger same family of larger class of different types of reaction, all coming under one umbrella, and that is beautifully observed in this olefin metathesis reaction. So, what we study as olefin metathesis actually is is a summation of different types of different classes of similar type of reactions, 8 variants of which I have just listed over here, and as in the next class we are going to look up alkyne metathesis, which also has its root from olefin metathesis, and we will see so many more variant of alkyne metathesis can also be explained by olefin metathesis, and hence one can sort of understand the beauty of metathesis reaction. What is also interesting to note in today's discussion is the fact that understanding mechanism is so important in understanding a reaction, because a proper understanding will help explain the mechanisms of so many different types of reactions. As for olefin metathesis only, we could see that this carbene active species and the cyclobutane intermediate in metathesis could explain 8 different variety of metathesis types of metathesis reaction as we have discussed today. In this context, I would also bring to our discussion in the previous course, where we had seen how this cross coupling reaction, palladium mediated cross coupling reaction, as first understood from Suzuki, or reaction Suzuki reaction could be also be translated to other variety, so many different types of other cross coupling reaction like Sonogashira, Negesi, Stili, and all of these reaction would also follow the same or similar type of mechanistic cycle involving oxidative addition, transmetallation, and reductive elimination. So, these also further illustrates the importance of understanding mechanism, and that is why we find so many different groups studying mechanism so seriously while understanding a reaction. So, with these today I am going to stop on today's discussion on different type of metathesis reaction. We are going to take up the another variant or variety of alkyne metathesis reaction in the next class. Until then, thank you for being with me, and I look forward to being with you when we discuss alkyne metathesis in the next class. Thank you and goodbye.